Very good afternoon to one and all. I'm Sita Malakshmi. On behalf of Griha Council and UNSW Sydney, I would like to extend a very warm welcome to all of you for the plenary session for the Waste Challenge. With 62 million tons of waste generation in India, less than 60% collected and 15% processed every year, India is ranking third in terms of greenhouse gas emissions from landfills, posing a great threat to the environment. A paradigm shift in the end of the line waste management to reuse and recycle waste at source offers a plausible solution. The CPCB National Action Plan for MSW 2015 has proposed material recovery facilities from household waste. Several entrepreneurial ventures have sprung up with the intent of upcycling waste. Large-scale policy-level measures and consumer sensitization could be the answer to managing the increasing concern of solid waste. This session aims to facilitate dialogue around waste upcycling strategies for value addition and minimizing waste disposal into landfills. The panel will discuss the challenges, solutions, and efforts taken towards solid waste management at the source. On that note, I welcome all the esteemed speakers, and I would now like to invite our moderator of the session, Scientia Professor Veena Sahajwalla, Director, Sustainable Materials Research and Technology, SMART, UNSW. Ma'am, please to come onto the dais. There's a photograph. I now request all the panelists to come forward for a photograph, please.
Oh, okay.
I now take the pleasure of introducing the esteemed moderator of the session, distinguished Scientia Professor Veena Sahajwalla, Founding Director, SMART, UNSW Sydney. Australian Research Council Laureate Professor Veena Sahajwalla is an internationally recognized materials scientist, engineer, and inventor revolutionizing recycling science. She is renowned for pioneering the high-temperature transformation of waste and the production of a new generation of green materials. She is also known for her internationally commercialized EAF green steelmaking process that is utilizing millions of waste tires otherwise destined for landfill. It's an honor to have you with us, ma'am. I now request Professor Veena Sahajwalla to introduce our esteemed speakers and take the session forward. Over to you, ma'am. Thank you.
Thank you very much, Sita, for that kind introduction. I just wanted to take only a couple of minutes to, I guess, tell you a little bit about what we're doing at UNSW. And I think to me, the colleagues that we have at UNSW, and in fact some of the amazing people we've met here through these last couple of days, actually is so inspiring. We've got people at UNSW, whether they're staff or students, are really excited about what we could be potentially doing with waste as a resource. And I think you'll often hear of terms like waste to wealth and creating resources out of waste materials. So for us, really, it's been very much about the journey of microfactories over the last many years that has now culminated actually in UNSW having its own microfactories. And I'd certainly like to invite all of you to, if you are ever in Sydney, to come in and have a look. I know that when Sanjay and Shabnam were visiting, that they were also having a look at this. And in fact, I think it was during one of those visits that we had a chat about what if we could have one of these tables at the conference, and that's where the journey started. So in fact, one of these tables that you see here on the podium is a table that's been produced in our own microfactories. It contains waste glass and textiles. And it just basically is one small example of how you can in fact take what might be considered as difficult to recycle, non-recyclable materials and convert them into value-added products. So I think it's about really challenging the norm and the notion that some things are just deemed non-recyclable. We have to be able to ask ourselves the question, why are we sort of putting things into these hard categories? Here are some things that are recyclable and the others are not, and so if something is not recyclable, we give up on it. And I think, to me, it's too easy to stop and give up on materials. But yet we've got to recognize that we as a society use more and more complicated products, right? You look at even something as basic as plastics, and that's going to be a bit of conversation on that in a few moments. Even plastics, there are so many different types of plastics. So again, we just can't assume that it's either recyclable or not. And plastics and more complex materials have evolved, and products have evolved. We see now plastics in our phones, in our cars. So if all of this is actually part of our lives, and we are using more and more complex materials. I'm sure you've seen many times with the resin code on plastics, and you actually see some of the ones where the numbers go from 1 to 7. And people are all familiar with the standard ones, like the one is our PET water bottles. We know PET water bottles are easily recyclable because we have the science, we have the technology to make it happen. But what about the other extreme? The extreme, which is resin code 7. And of course, let me just tell you that when people put all of these different types of materials of different plastics into the category 7, it simply just means that we don't know yet how to recycle it, because sometimes it could just be those rather challenging and difficult polymers that were actually designed for a purpose. So it's not as if they're bad materials, and I think this is where we need to be able to understand that materials have been designed, with a purpose in mind. So you look at something like glass and you go, right, glass should be recyclable. But the realities are that there are so many different types of glass. The safety glass that's there in your car windscreen is not the same in terms of product as what you would put in your domestic glass stream. So the fact that the safety glass is designed for a purpose, and the purpose is to keep us safe in case of an accident. So you've got all of these different materials and products that serve a certain purpose, a certain function. At the end of the day, it's about functionality, which of course includes, keeping all of us safe. And so the fact that you hear about safety glass, tempered glass, I just want to give you that as an example, that even something as basic as glass, that we might look at it and go, right, okay, all glass is recyclable. But all glass may not be recyclable in the exact same way. So just like the products have evolved over time, our recycling and reforming solutions have to also become a lot more sophisticated in the way we look at our products. Therefore, recycling strategies cannot just depend upon what we used to do many, many years ago. We now have to say, right, what is it that we need to achieve in terms of getting the best value out of our waste materials and our waste products? So this is when we start to think about waste as a resource. And if it is going to be a resource, it can only be a useful resource if it is put into manufacturing. So if you actually manufacture something that's high value, then of course, very clearly, the market will support those types of manufacturing solutions. So that's really what it's about. It's about understanding the economic value and what in fact market will in fact use. And on the other hand, from a scientific perspective, are these solutions safe and sustainable? So yes, it's a complex, multifaceted problem, but it can also be converted into a fantastic opportunity. And that's really what we're doing at UNSW. Our microfactories are about really creating innovative solutions around recycling and what we like to call the 4th R of reforming our waste into value-added product. Why is it 4th R? Because the 3 R's of reduce, reuse, recycle are the obvious things we all should be doing. Of course, we should be reducing our consumption of materials, and of course, we should be reusing it and recycling. But when it comes to the more complicated products, we have to be able to look at reforming it into new value-added materials and products. So this is where, of course, examples of, being able to take things like batteries and our electronics and automotive waste, all of these types of more complex materials coming out from the things that we take for granted, right? We just take for granted that, you know, there's plastics in cars. Of course, plastics was put in cars to reduce the weight and therefore reduce our fuel consumption. So should we say that's a bad thing? No, plastics was introduced for a purpose. It's of course a material that can be used for manufacturing, can be molded into different shapes. Again, you've got glass that serves a very important purpose in so many different applications, and of course metals and rare earths, and the list goes on and on. So the important thing is to recognize that all of these products that we talk about have actually got so many important materials embedded in it. It's how we actually get to those valuable materials and how we actually reform them through manufacturing processes. So our microfactories at UNSW are about taking waste glass, waste textiles, plastics, and of course we launched last year the world's first e-waste microfactory. And through this e-waste microfactory, we can take something as complicated as a printed circuit board where there are many metals, there are rather difficult polymers, and there could well be some ceramics in there, and convert that into valuable alloys and valuable carbon products by completely reforming it. So in many instances, the polymer actually transforms into higher order, higher value carbon, because polymer fundamentally contains a lot of carbon. So when we talk about micro-recycling, which is what microfactories are based on the science of, we're actually saying that every element, every compound, every molecule that is present in these different types of products becomes a resource. How you transform those molecules depends upon ultimately what you want to make. So if you want to make a product that is fundamentally a whole new ceramic through a combination of waste glass and plastics, you can do that and you can create a whole new ceramic compound like silicon carbide, where silicon comes from waste glass and carbon comes from waste plastics. Because as we know, glass contains silica. So it's a great source of silicon, and plastics is a great source of carbon. There are many, many other useful elements that are embedded in our waste resources. And if we can actually start to think about recycling and reforming at the much more molecular and a fundamental level, then basically what we are saying is that potentially nothing should go to landfill. If we actually can devise science and technology to enable us to carry out that transformation in a way that is safe and sustainable, then nothing should go to landfill. So I'm just going to scroll through a few slides just to show you the kinds of things that we are doing at the moment at UNSW. So let's just move through that. Sorry, I'm not getting this to move forward. Okay, so these are just some examples, and look, I'm not going to spend too much time on each of these. It's just to kind of give you a bit of a sense of, you know, how in many, many parts of the world, of course, including in Australia, a lot of these products that have now become obsolete have in fact ended up in landfill. But the realities are, you look at systems like this and you go, right, that polymer in the hardware that you see in some of these old monitors, are they really sort of useless? No, of course not. Just because the product is no longer useful doesn't mean that the materials that are there are useless too. The materials in there are actually really useful. It's about how you bring it back into production. And of course, I was talking about circuit boards, to the endless opportunity with examples like e-waste. And of course, there's lots and lots of information where UNEP and many other agencies talk about the value that's embedded. And the value is not just there from the metals. The value is there in basically the organic materials and of course in our ceramics as well. I just wanted to finish off in just a moment by giving you a bit of a sense of this particular industry partner site. So you'll see this is our e-waste recycling partner in Sydney, and we are partnering with them. One of our micro factories is being piloted on their site. And of course, following on from this is footage that some of you may recognize because it was shot not too far away from here in Seelampur. And when we were visiting Seelampur and a couple of parts of New Delhi, I think to me what was really exciting is that small manufacturer you see there, the guy who makes torches, said to me, you know, I'd love to be able to use waste plastics in producing the kinds of torches that I'm making. I'd love to be able to use metals in what I'm making. So I think to me, the passion and the desire amongst small producers, medium producers is absolutely there to use recycled content. And of course in Sydney, in this particular industry partner site, who was literally, as you see, a whole lot of stuff coming from our homes and offices in Sydney and other parts of Australia are indeed now being looked at in terms of creating valuable products. So what we do with our waste plastics is we convert them into plastic filaments. We use those plastic filaments for 3D printing. So that's an example of a technology that we're developing in partnership. And of course, we've used a whole range of other waste materials like tires that you heard in the introduction, and plastics in the process of making steel. So I'll leave it at that, and I want to, of course, get to our esteemed panel members who are here today. And we're going to take a really exciting approach. We're going to actually, instead of getting them to come up here and give us a short lecture, they've all very kindly agreed to indulge and be part of this experiment. And I can see Veena and James kind of nodding away, my colleagues from UNSW going, see how this goes. But I promise you our panel members are very excited about this conversation that we're about to have. So I thought I might begin by introducing S.K. Ray. And, while he is, I kind of, alluded to him a little bit that the conversation would have a few surprise elements in it. I think he said he was prepared for it. He was ready for the challenge. So I love that. I love that approach. But before I start the questioning, I thought I might give you a little bit of an intro on Shri S.K. Ray. He has spent and has had over 43 years of experience in the petrochemical industry. He has business, market development, corporate affairs responsibilities at Indian Petrochemical Corporation and at Reliance Industries Limited. And of course, what I love about his bio is that he is presently mentoring the newly formed sustainability group, which is very, very inspiring. And of course, a whole range of amazing achievements that he's had in his life. But what I thought I might do is I might use my podium and my mic here. If I can get you to grab the mic that is there, thank you. And if you can, if you're mic'd up, that's okay, whatever you prefer. If you would prefer to, if that's not working, if your mic there is working, that's fine. And if you prefer to sit down or stand up here with me.
Okay. With you, that is better, I guess.
Why not? It's a conversation.
Come closer to a professor. Yeah.
It's a conversation,
Yeah,
right?
Sure.
So let's have a conversation about, I know that you are very passionate about plastics, particularly in the form of packaging. And I know that, of course, we all as end users, so we're all end users, we know we use plastics in our everyday life as part of packaging. Can you tell us a reason why, society has evolved to this point where it's such an important part of our everyday lives? We kind of take it for granted, right? Can you tell us why?
Yes. With your introduction, I think you have made my task very simple. You have articulated that these materials are new materials. First of all, we haven't had an opportunity to know this material for too long. It's just about 5 to 6 decades that we are using plastics extensively. And the reason we are using plastics is basically it provides three very important, it carries out three important functions. Number one is it's able to keep the product that we pack safe, and it lasts much longer, particularly for food product. And in the process, we are able to save a lot of food otherwise which used to get wasted. I recall my childhood days. We used to have bread wrapped in wax paper. That bread used to last us for a day or two at best. And after that, my mom would say, stale, now you throw that bread out. Today, my wife does the same thing. She keeps it for 5 to 6 days. When it comes wrapped in a plastic wrapper, added to that, we have the cold chain at home in the form of refrigerator. So the food stays much longer, and we are able to utilize that food for the bread for next 4 to 5 days. So number one, it's protecting it. Number two, it is extending its shelf life. And number three, it is also extremely affordable. It is affordable as well as convenient. So that is one of the reasons, because that is the reason I believe that it has played a very important role in terms of in keeping the product safe, longer, and at an affordable cost.
So I guess is that, I mean, you think about so many countries of the world, you talk about food, and let's sort of focus on food packaging for a moment, because I think the points you've made are so important. You know, how do we get food across to so many parts of the world where it is desperately needed? And do you feel in a way that there is this other side of it, that our ability to extend the shelf life of food has happened as a result of some of the plastics, new materials that we are using? Are there specific food grade plastics that you can perhaps tell us? You use the bread example. Perhaps what the audience might like to know is, what are the food grade plastics?
Basically, most of the plastics, I think you made a point that there is a wide range of plastics. Roughly there are 22 different types of plastics, and within that 22 different types there are also specific grades. So if I break them up into different types, it probably will run into few thousands. One estimate says it is 8,000. Okay, that's an industry estimate. And each of these grade has a specific use. Fortunately for us, bulk of the plastics are inert in nature. So they do not interact with the food that is packed, and certain plastics which may have a concern are not actually recommended for food applications, and those are not used in the food packaging applications. Bulk of the plastics like polyethylene, polypropylene, PET, polyethylene terephthalate, you gave an example, these are all very safe as far as the packaging of food product is concerned, and that's why we use it extensively.
So is it possible that we can imagine a future where we do keep that segregation between and sorting out the ones that are food safe, so that remains in one stream, and the other, rather the other grades that could be more for industrial purposes can be kept safe, so you can avoid that cross-contamination?
It is happening. As a matter of fact, if you look at the food producers like Nestle or Pepsi, they know this, they understand this material pretty well, and they would not be using a particular type or grade of plastic which is not approved for food applications. As a matter of fact, we have international standards where you should which material to be used for food contact applications. There are also materials which are not recommended for food contact applications, and those are not used in that application.
So that means that actually it lends itself automatically for better and better recycling solutions, because you're starting on the right footing.
Correct.
Which is great. I think you've made a very convincing argument. Thank you very much.
Thank you.
And that's been fantastic chatting to you.
Thank you.
Round of applause for Mr. Ray. I'd like to now invite our next speaker to give us his thoughts and share his experiences with us. Mr. Nitin Gupta is a co-founder and CEO of Attero Recycling, and he has had incredible experience in the whole world of e-waste, which I think there is no doubt that one of the biggest emerging challenges. But he's also mentioned to me that in addition to that, he also is now starting to think about the all-important question of lithium-ion batteries. So really excited about, some of the things that you are looking to doing. Can you tell us a little bit about what plans you have with lithium-ion batteries recycling?
So Professor Veena, we are actually recycling lithium-ion batteries in India today. We are extracting pure cobalt from them, lithium carbonate, pharmaceutical grade, graphite, nickel, manganese dioxide, copper, aluminum, iron, and plastics, right? And the batteries are 100% recyclable. We have applied for more than 16 global patents on this technology that we've developed in-house. And we're looking to set up these plants outside India, in the US and Australia also.
That's great. Well, can you share with us, what actually, from a technological perspective, are the challenges? Because of course everyone realizes that recycling batteries is a big challenge. What are the actual sort of challenges? Why is it that the world has struggled so much in recycling waste batteries? And let's pick up batteries more broadly. So whether it's lithium-ion batteries or nickel metal hydride, there's also NiCads. I mean, to me, the worry with things like NiCads, so that's nickel cadmium, is that you've got toxic elements like cadmium that are present. So I think we need to bring into this conversation the toxicity of some of the materials that are there in our batteries, which means that a lot of traditional recycling strategies may not necessarily work, because we've got to be mindful of the impact on not only the health of our planet, but health of the people who are working in that space. So can you tell us a little bit about some of the challenges?
No, a good point. So few things. See, Well, you look at any battery. So the most recycled battery in the world today is a lead acid battery. The reason for high rate of recycling of lead acid batteries is lead is in high abundance in a lead acid battery, and it can be extracted pretty easily from a technological standpoint. So there are many mom and pop shops across the country and across the world which are able to take this lead out by a smelting process. Now please remember that process might not be completely environmentally friendly because lead fumes go in the atmosphere and they hurt the people working in that particular unit, but also hurt the general population per se. But lead is a valuable commodity, it is easily extractable. So the collection rates and recycling rates of lead acid batteries today are very, very high, right? Some companies and some individuals are working on figuring out an electrochemical solution for lead acid batteries, and that's where the point that you made, Professor Veena, comes into the picture. If you are able to find out the right technologies for recycling, whether it's batteries, electronic waste, plastics, glass, or all kinds of hazardous waste that's out there, then almost 99% of the problem is solved, right? When I talk to people, people say the biggest problem in waste management is collection. Probably that's not my opinion, right? The biggest problem is how can you extract value from waste? If you're able to extract value from waste, then you can create a supply chain which transfers this value and you can actually get hold of as much waste as you want to recycle. So the problem is how can we figure out technological solutions which can turn into commercial successes, right? Now coming back specifically to, let's say, lithium-ion battery or nickel-cadmium battery, the challenges in battery recycling are manifold. First, lithium-ion batteries are known to catch fire, right? They are very hazardous from a fire perspective. So if you store them for quite some time, then the biggest problem is, or if you dispose them in a common treatment facility, then there are chances of fire, and that's a big hazard out there. So how do you neutralize that? How do you ensure maximum recovery of the materials in there, right? It's not only a waste problem, it's also a supply issue. Most of the cobalt that's mined in the world comes from the DR Congo region, where there are terrorist regimes, child labor, all kinds of problems out there. How do you ensure that we don't mine further cobalt? How do you ensure that there's lithium security out there, right? So both of these points, and you need to ensure that you're able to extract the maximum amount of metals that are present in these batteries. To do that, chemically and metallurgically, it's a complex technological issue. Cobalt, lithium, graphite, manganese, each of these metals have their own smelting points, chemical behavior, and when they're present together, they influence each other's behavior. So put in simple terms, as the amount of metals in the input feedstock or elements in the input feedstock increases, more difficult is a technological solution to extract these metals in abundance, right? So a couple of things. For example, in our process plant, you'll see an electrowinning cell where on one side cobalt is electroplated, on the other side manganese dioxide is electroplated. That's one patent that we've applied for. So it's the first time you'll see in the world two simultaneous electroplating of different metals, right? So the challenges from a technological standpoint require deep research, both from a chemical perspective and metallurgical perspective.
And I'll just pick up on one point you made earlier, which is maybe something that the world needs to be a little bit more careful. I mean, I know you sort of mentioned it very briefly, is around safety, because you talk about lead fumes.
Yes.
And I think to me, it's like, sort of making the point that we recognize some of the toxicity that's already been around in our environment, things like lead and asbestos and a lot of these materials that have been around. I think there are two issues, right? One is, of course, we have to challenge ourselves in saying, why are we using toxic materials in the first place? And I don't think we should be. So I think to me that's a really important point. The other point, of course, is recognizing where we have legacy products that are already there. How do we deal with them in a safe manner? So would you agree that in addition to thinking about commercial and economics bottom line, if we talk about sustainability, we absolutely need to care about the well-being of our planet. We need to care about the well-being of our people who are working on it. So you can't have profits at the cost of our planet and our people. So
No, definitely. See, profits alone from a financial standpoint will not be enough, right? That's never enough. So sustainability or profit is a word that I use comminglingly is for a broader perspective, right? Now, from a material removal standpoint, ROHS compliance is already there. A lot of people are trying to figure out how can they reduce hazardous substances in the input product itself, right? And on top of it comes the recycling solutions. How can you figure out from a technological standpoint, you're able to extract these metals, make it the most environmentally friendly process, make sure these waste materials are not going to the landfill, but are being used for a useful product in the society. On top of it, if you can add a sustainability angle to it to finance the entire supply chain, that makes it even more better. So just to add to that, Attero is the only company in the world which gets carbon credits per ton of electronic waste recycled, right? The reason for that is our recycling process is so energy efficient that UNFCCC has agreed that it's better than mining. So today from electronic waste in India, we extract pure gold, pure silver, pure palladium, all the rare earth metals, right? So from a sustainability standpoint, there are various ways to look at the entire process and come out with a solution which is a win-win-win for everybody.
Fantastic. And on that note, thank you very much, Mr. Nitin Gupta. Thank you. All right, my next panelist, Dr. Sunil Pandey, is a Senior Fellow and Director at the Center for Waste Management at TERI, and has been very excited about the work that's happening here at TERI. And I think to me what's really even incredible is that every time I come here to TERI and have discussions with so many incredible smart people, it's always very inspiring to hear some of the work that you're doing. So Sunil, I know that you've been working in so many different aspects, and of course your work, regulatory and policy as well, at TERI University. So I think to me that's an important sort of point that we'd love to hear a little bit more from. We've talked about some of the technical challenges, but perhaps if you could tell us a little bit more about how you see, I suppose, both for India and for the world more broadly, what kind of regulatory and policy frameworks we will need.
Yeah, thank you, Professor Veena. And what I'll, for the regulatory challenge, what I like to immediately point out is, our regulations have, like international regulations, have built in concept of EPR, which Nitin is also familiar with. Now, we are...
Perhaps you might just want to tell the audience what you mean by EPR.
Is extended producer responsibility. So, producers are made responsible for the products which they are sending to market. And it's basically their responsibility, whether it's joint responsibility or alone, they working alone, to also ensure that the product, when it becomes a waste, is managed in a proper manner. And we have been struggling nationally on how this EPR framework should look like, and how to ensure that, because our market is full of not only branded product, but also products which are not branded. Not branded, or brands which are not kind of very rich brands. Anytime when you look at waste stream, you can point out manufacturers which are generating to certain kind of waste, but there will be a lot of waste which will be unaccountable. So how basically EPR can be implemented in such scenario? So what Ministry of Environment and Forest has now been doing is that they're coming with a framework for implementation, where they're looking at targets for various manufacturers, where they're looking at how this EPR can be implemented, where they can work jointly with regulators like Central Pollution Control Board in the country, different urban local bodies, and kind of come out with a system which can ensure collection. Because what is happening is we have recycling facilities in place, but they're not getting enough waste to recycle. So that's a challenge which EPR is trying to address.
Do you think that you need to incentivize consumers, retailers to participate more proactively in schemes?
Sure. It's already happening to some extent. If you look at another waste stream which is neither, it's a plastic based, but it's a challenging stream which is called multi-layered plastics, which you use for packaging your crisps. So there recently manufacturers have started incentive scheme, not for consumers, not for retailers, but for the waste pickers in the country. Because unlike many other countries, India has very vibrant waste picking sector, which removes almost, if you look at city-wide statistics, in most cities they remove around 15% of waste every day from the waste stream. So, manufacturers have come out with incentive schemes to basically ensure that these are also picked up. And what we are looking at in terms of its processing, that if they can be kind of guided to cement kilns, where they can be used as alternate fuel for producing cement. So that's something which has started now.
And you're also sort of looking into building capacity. And how are you actually doing that? Is that capacity amongst, say, waste pickers, businesses, kids who are going through university? How are you actually going about doing that?
It's actually addressing not only youth, through government programs. Also, I mean, different NGOs which are engaged in educating youth. We ourselves have active program on waste management where we are engaging not only school and college kids, but the other youth as well on how waste can be managed in a more responsible manner. We are working with various corporate sectors and with their CSR funding in bringing in awareness on waste management. And we have found that, I mean, if you start right from the school stage, the message goes more effectively. And kids certainly can influence their parents as well because they have a lot of voice at home. And I mean, that is certainly showing results. We are hopeful that, I mean, since it's a cultural issue, it's a behavioral issue, it takes time changing.
Sure.
But it's going in the right direction.
Just for the benefit of people in the audience, you mentioned CSR. Again, would you like to just quickly explain what you mean by CSR? And for people, perhaps it might help if you want to give an example of CSR that's working well.
Sure. I mean, CSR basically stands for corporate social responsibility. And what government requires is that certain percentage of profit, 2% around? 2%. Of the profit, industry has to spend in activities which reflect their social responsibility. Now, since advent of the Swachh Bharat mission in 2014, what has happened is corporate sectors can also now spend in activities which are relating to waste management. And I mean, there are corporate sectors, corporate sector partners, like for example, Reliance is doing that, NTPC, National Thermal Power Corporation is doing that, IOCL is doing that, a lot of such public sector and private sector enterprises. ITC is doing that now, basically for managing the waste in a better manner. Also engaging with waste pickers, because one of the mandates in the regulation is to formalize or not formalize, but to integrate the waste pickers into formal waste management system.
No, it's fantastic. So it looks like a lot of things are happening in India, and certainly something that we'd love to continue to keep an eye and see what's happening and perhaps learn from that experience.
Sure.
So thank you very much, and please
My
join
pleasure.
with me in thanking Sunil. And certainly last but not least, I'd like to invite Ms. Radhika Abrol, who is the Municipal Councillor for the South Delhi Municipal Corporation. And we're really excited to have you to tell us a little bit about, because I can imagine that working in a municipal corporation and, you know, wearing that hat of local government. I know in Australia also we've got local governments and state government and federal government, and of course various sort of tiers of responsibility in your role. I'm sure it's not an easy task. So can you, just for the benefit of the audience, tell us a little bit about the municipal corporation, the South Delhi Municipal Corporation, and what is your responsibility in that?
Well, very good afternoon to everyone. Thank you for giving me such a brilliant introduction, though the work we do is not as brilliant as it sounds or as it reads on the paper. So basically the municipal or the municipality is engaged, and the main purpose of it is to, how basically should I say, to clean the roads, to make places free of garbage, to let people know that ultimately you have to join hands with us if we need to improve our nation. So the main task for municipality is this. Apart from that, yes, there is building of roads, putting of lights, and a lot many other things. But the backbone of any municipality should be the management of waste, and that apparently happens to be the topic over here also. So our main role is to engage people. If my presentation was to run in the background, I have specifically focused on the fact that how difficult it is for us to engage people, because they have very rigid belief systems. There are very rigid belief methodologies people have. Say, for example, I'll pick up a very small thing, and all of you might just relate with it. People dispose of the religious waste under trees, and then they also have a tendency to make a boundary around it. So technically that boundary counts as an encroachment on the public land, which in itself is a bigger problem than managing the waste. So even if we try to tell them, even if we try to get in touch with them, we try to convince them that don't do it, and it should be disposed of in the same manner as anything else. I'm also a religious person, but what religious thing are we doing by putting those things under a tree and apparently blocking the tree's source of water and maybe sunlight also at times? So this is one thing which we have to deal in every household, because they won't just listen to you. They won't listen to you because for somebody in our country, it's a little difficult to listen to what's right. So, yeah, that's
I can
one
see
thing.
your task is really, really challenging. And I suppose, I mean, what might be, useful, you've sort of set us on this journey where you've sort of picked up on what are the challenges if waste is not managed properly. But can you give us an example of some of the initiatives that you're doing as part of your responsibility within the municipal corporation, where you can kind of shed a bit of light on how you actually brought about that change, as you say, behavioral changes, how you've actually gone about doing that?
See, I would just in very few words say this, that I am lucky to have people with me who understand the importance of all this. So I also have them along with me here. Obviously, I won't take their names, but there are people who are ready to engage with you for the right thing. So there are what we call the RWAs, the Resident Welfare Associations, which is actually selected by the residents themselves. So even if you find it difficult to reach an authority, say for example me, so they would first engage with the people who are in their own level, the local people. So one or two things that I would like to point out is that what SDMC has done is, SDMC has done a tremendous work of waste to art. If you go to Sarai Kale Khan, you can see the Seven Wonders Park over there. The entire thing is made out of waste. Iron, tin, tires, plastic, the same plastic that you mentioned you use in the cars. So it's actually difficult to dispose it of, because what we can actually put it to use. We don't have to just throw it at a landfill or just crush it over somewhere and put it. So it's made out of that. A similar thing is also there at Green Park. That is where I come from, which is it's an urban colony in South Delhi. And there's a beautiful structure which is lighted in the night, and it has names of all the historical places in Delhi. So that is also made out of waste. Another thing is the vertical garden, which is there at the office of the SDMC, which is in Green Park again, which is again made up of waste. So you need to understand, and all of us need to understand, that if it was not used for that purpose, it would have just gone to the landfill, or maybe it would have been just disposed of at a roadside or somewhere like that. Because we as Indians, even I have that tendency. So it's not that I'm looking down upon us, but we as Indians have a tendency that wherever we see waste accumulated, we mark that as a dumping ground and we start throwing over there. So it is from these places that we have picked up the waste and actually made all this. You can see the tires in this picture. These are also tires which were just discarded off. The car was discarded, the tires were discarded. So this is actually all waste products which are put to such amazing use. And these are sites that you should really come down and visit once at least.
I like your, sort of the point you were making about residents, and residents, really taking that responsibility. So I suppose it goes to show that to some extent, a lot of these things have to happen at the grassroots level. And do you find that once you get something started at the grassroots level, there might be other communities who also kind of go, look at that and think, well, we can do something similar. So whether that also then inspires a whole wave of people wanting to do similar things. Are you starting to see a little bit of that happen?
Well, on that note, I would just say one thing, that if you actually follow me on Twitter or Facebook.
Go on, tell your Twitter handle.
My Twitter handle is Professor Radhika Abrol. So there are a lot of IDs by Radhika Abrol, but Professor one is the official one. And I have my page on Facebook as well, which goes by the name of Radhika Abrol, Fogart being my last name. So that is also managed by me. So the point is that I'll just take a minute, because I can see the time is already out. So I'll just take a minute and wind it up. That once we started with a good project, I was so happy that many big companies, big firms, Airtel being one of them, joined hands with us in doing our project. So what I really started with, I have to tell this because I represent the municipality and people think that municipality does nothing. Honestly, if municipality was doing nothing, we people would not have walked on the roads. They do. But there's a limitation to us also, and we need to understand that. So all our funds and everything comes down from a lot of levels. It's not directly that we have anything in our hand. So one big thing which we did as part of the municipality, and Mr. Pandey is also here who would agree with me, that somewhere we have a challenge of cleaning up the roads which are like those smaller lanes, the by lanes. It's a big challenge clearing them out. So SDMC, the South Delhi Municipal Corporation, has actually imported a lot of vehicles to do that. So you might just see them running around. This happens to be an NDMC area, New Delhi Municipal Corporation, which is anyways A1. So a lot of things you can see, even in this presentation I've aimed at this. This was the anti-plastic drive which happened, which our Honorable Prime Minister had started. So a lot can be said, but I just feel that one should always restrict the words and make your actions infinite so that you are known for what you do. So I think that's all that I'll say.
That's fantastic. What an inspiring woman. Thank you. Perhaps you can keep the mic there and just see. So I know we've sort of run out of time, but what we might do is, if there are any burning questions, perhaps we can accommodate a question maybe. Otherwise, we've run out of time, so I'm a bit sort of careful that we don't have. Yes, I think we have one there. So mic.
R.K. Sharma, consultant head at District Development Authority, Nainital, Uttarakhand. सर हिंदी में पूछ सकता हूँ? शायद मुझे लग रहा है हिंदी कोई नहीं बोलता, तो मैंने बोलने की हिम्मत इसलिए
हमें भी ज़्यादा समझ आएगा आप हिंदी में बोलोगे तो.
थैंक यू. सर आप एक रेनाउंड प्लास्टिक टेक्नोलॉजिस्ट रहे हैं, जैसा आपके बैकग्राउंड को देख करके बताया है मैम ने. सर हमारे उत्तराखंड में एक ग्रोइंग जो समस्या होते जा रही है वो प्लास्टिक मैनेजमेंट की है, क्योंकि मैं इधर सिटीज़ में देखता हूँ, यहाँ तो लोग काफ़ी मोटिवेटेड हैं. जैसे मैम का वर्क है, मैं मैम को फॉलो करना शुरू करूँगा आज के बाद से. हमारे यहाँ के काउंसलर के अंदर तो इतना सा भी तमीज़ नहीं होता है, सीधी बात. तो मैम रियली सल्यूट है आपको. हमारे यहाँ 60 वार्ड मेंबर्स हैं, बट कोई भी इस तरीके का आपके आसपास नहीं पहुंच पाता. तो पहले तो सिविक बॉडीज के होते नाते आपको
बिग हैंड टू मैम.
अब सर एक एनलाइटमेंट आपसे ये चाहिए कि बहुत कम समय में, ज़्यादा समय नहीं लूँगा, कि हमें अपने इस प्लास्टिक वेस्ट को जो हम सेग्रीगेशन करके हमने कुछ स्कूल्स को पिकअप किया है, और मैं पर वीक बच्चों को अपनी पॉकेट से इंसेंटिव देता हूँ. गवर्नमेंट स्कूल्स मैंने वो किए, तो वो अपने घर से मिल्क के जो पैकेट्स होते हैं, दूध की थैलियाँ जिनको कहते हैं, वो लेके आते हैं. तो सर आप कुछ ऐसा एनलाइटमेंट दीजिए कि हम उसको म्यूनिसिपल कॉरपोरेशन को जो डोर टू डोर गार्बेज कलेक्शन जो व्हीकल आती है, सर उसके बाद उसका क्या कर सकते हैं, थोड़ा सा एक आप एनलाइटमेंट दीजिए. थैंक यू सर.
बहुत अच्छा क्वेश्चन आपने पूछा है. एक्चुअली आई वॉज प्लानिंग टू टॉक अबाउट इट. हम जो कहते हैं कि प्लास्टिक जो हम रिसाइकिल करते हैं, वी आर डाउन साइकिलिंग इट. एक्चुअली वो दैट परसेप्शन वो ठीक नहीं है. विद दैट परसेप्शन एक्चुअली हम लोग क्या कर रहे हैं, वी आर अंडर एस्टिमेटिंग द इंजेन्यूटी ऑफ ह्यूमन बीइंग. सिंस आपने ये पूछा है, मैं एक आपको उदाहरण देना चाहूँगा. ये मेरे पास एक बैग है. कैन आई गिव इट टू यू? ये जो है ये पीईटी बॉटल जो हम फेंकते हैं, उसी में से रिसाइकिल करके ये बैग हमने बनाया.
अगर ये बैग मुझे मिल जाएगा तो ज़्यादा अच्छा लगेगा.
I think
आपने बोला कि प्रोफेसर साहब के पास आकर के अच्छा लगता है, तो
ये बैग आप खोल लीजिए. ये जो मैं कह रहा था कि ह्यूमन इंजेन्यूटी को हमें एक्चुअली देखना चाहिए. प्लास्टिक्स नीड नॉट बी डाउन साइकिल्ड. हाँ, श्योर. ये बैग जो बनी है, ये पीईटी बॉटल, प्लास्टिक वाटर बॉटल से बनी हुई है. ये जो है ऐसे बहुत अच्छे हैं. इसमें क्या खूबी इसमें है, द ह्यूमन human ingenuity, this is very critical. I think what we really try to understand is that we can make wonderful product provided we look at waste as a resource, what madam is saying. And once we look at it as a resource, I think there are a lot of opportunities that can be really tapped. Today plastic का जो recycling जो है, उसमें कमी जो हमें लगता है, that is basically our attitude in terms of managing the waste. And once the waste is managed in a scientific way, there are huge opportunities which are there, and a lot of people are getting into this space today in terms of recycling and pursuing the circular economy tenet. Yeah.
Absolutely. Well, I will, on that note, please join with me in thanking all our panel members. I'm sorry, I think we've run out of time for the questions, but Thank you to all our panel members, and hopefully you've all been inspired today with all of them doing some incredibly amazing work. So thank you so much for the opportunity to be a part of this fantastic conversation. I'd like to thank Sanjay for the invitation to come and, sort of meet amazingly inspiring people. And thank you so much for your interest and for coming along. And look forward to seeing you again next year. Thank you.
Thank you very much, Professor Veena Sahajwalla, for moderating the session so beautifully. I would now request Professor Veena to present a small token of appreciation to our distinguished speakers. Mr. S.K. Ray, Honorary Secretary, Indian Center for Plastics in the Environment. Mr. Nitin Gupta, co-founder and CEO, Attero Recycling. Dr. Sunil Pandey, Senior Fellow and Director, Center for Waste Management, TERI. Ms. Radhika Abrol, Municipal Councillor, South Delhi Municipal Corporation. Thank you, ma'am. I would now like to request Mr. Sanjay Seth, CEO, Griha Council, to present a small token of appreciation to the moderator of the session, Professor Veena Sahajwalla. Thank you, sir.